Isotopes. In this screencast, what I'm going to do is to talk about isotopes, but before that, review atomic structure, talk about isotopes, isotopic notation, and then do a practice problem with you. So this is a picture of the periodic table, and as you know, we have the elements, and an element is a collection of a particular type of atom. For example, if we have the element carbon, right here, that would be a collection of carbon atoms. Atoms are made up of smaller things, protons, neutrons, and electrons, and even smaller than that. But let's stick to this level. So this would be an illustration of the structure of a carbon-12 atom. There's the nucleus, and then we either show electrons in electron clouds or orbiting the nucleus. So our subatomic particles, there are three that we'll be talking about today. There are protons, which have a positive charge and a mass unit of 1, and those are in the nucleus. Also in the nucleus are neutrons, which have a mass number of 1, relative mass number of 1, and they have no charge. And then balancing out the protons, a positive charge, are the electrons orbiting around the nucleus, and they're so light, their mass is negligible. Nobody even includes it in the atomic mass for the most part. So when we look at the element carbon, in particular carbon-12 on the periodic table, we see two numbers attached to it, the number 6 and the number 12.001. So the number 6 is the number of the atom. That's called the atomic number. It's the number of protons in the nucleus of that atom. A neutral atom is also the number of electrons. And we have the mass number lower than that. So the mass number is made up of the subatomic particles that have a noticeable weight. So that would be the protons and the neutrons. And it's not a whole number because it's actually a weighted average of all of the atom's isotopes. So weighted average, meaning that there are different forms of carbon. Right here we're looking at carbon-12, but there's other forms of carbon. So we know an element is a collection of the same type of atoms. So the forms of carbon are called isotopes of carbon. So an isotope is the same atom with a different mass number because it's got a different number of neutrons. So for example, with carbon, we have carbon-12, carbon-13, and carbon-14. They all have 6 protons and they all have 6 electrons, but the neutron number is different. So in carbon-12, there's 6 neutrons. So 6 and 6 makes our mass number of 12. In carbon-13, there's 7 neutrons. 7 and 6 makes the mass number of 13. And in carbon-14, there's 8 neutrons. 6 and 8 makes the mass number of 14. So these would be isotopes of carbon. I like to think of isotopes a little bit as like little bags maybe. And like we have bag A and bag B right here. So they're both the same form, but they have a different weight in the inside. Let's just say this bag right here has like 18 tennis balls in it, and this one here has 16. These could pass for the two isotopes of oxygen. There's oxygen 18 and oxygen 16. Let's take a look at what I mean. Again, oxygen 16, oxygen's atom number 8 on the table, 8 protons, 8 electrons, but a different number of neutrons. Different amount of neutrons in the center of that atom. Okay. When you're learning about isotopes, you'll often have to learn how to express them, isotopic notation, or sometimes your teacher may call it nuclear notation. So there's 2 ways to express isotopic notation. The easiest way is the element name, a dash, and the mass number. And another way is the element symbol with a superscript, super being above, a mass number at the top, and the atomic number at the bottom. For example, we have 3 isotopes of hydrogen. They're all hydrogen because they all have an atomic number of 1 proton. But if, as we can see, hydrogen 1 here has just 1 proton in the nucleus, a mass number of 1. Hydrogen 2, deuterium, has 2 particles in the nucleus, a neutron and a proton. And hydrogen 3, tritium, has 3 particles in the nucleus, a proton and 2 neutrons. Okay. With isotopes of hydrogen, they each have their own name, protium, deuterium, and tritium. Just a quick point, isotopes have the same chemical properties. So you probably heard of water. The formula for water is H2O. So hydrogen, all forms of hydrogen can bond with oxygen to make water. Regular water, protium is the most abundant isotope, and H2O we think of usually as with protium. But if deuterium, remember that was hydrogen 2, bonds with oxygen, some people write it as D2O, and they call it heavy water. Because remember, deuterium is a heavier isotope. The other thing you should realize is that some isotopes are unstable, and such is the case as with tritium. Tritium is radioactive. It has an unstable nucleus. So what happens is, in the nucleus, a neutron can decay. That's one type of radioactivity. When a neutron decays, it breaks down into a proton and an electron. So the electron shoots out as a high-speed beta particle. And so what happens is what's left in the nucleus is an additional proton. So let's take a look at what's happening here. So when tritium decays, it transmutates into helium. It transmutates from atom number 1 to atom number 2 because the decay of that neutron makes another proton. Okay, so tritium has 2 neutrons and 1 proton, and when it transmutates, helium has 2 protons, making it helium, and 1 neutron. Let's do a quick practice problem. Let's just say that this was a typical problem. An isotope contains 6 protons and 8 neutrons. Construct the symbol of the isotope. When you see 6 protons, you've got to know that is your atomic number. So straight away, you can look up your periodic table and say atom number 6, that's carbon. So you know you've got a 6, and you know atomic number goes down here. All you've got to figure out now is the mass number. And the mass number is made up of protons and neutrons. 6 plus 8 is 14. That's the mass number. And this is a notation for carbon, 14. Okay, thanks.